Hello everybody, this is Mrs. Snook with section 2.8, Quadratic Regression. And what we're going to do today is we're going to make scatter plots and we're going to determine if a quadratic regression or a linear regression is better. And then we'll actually calculate the regression using our calculators. So the first thing you need to do is clear out anything you may have left in your calculator. So I have that equation. I'm going to clear that out. I am also going to go into Stat, Edit, and you see I have some data in here. So I go to the top, clear, enter, go to the other one, clear, enter. All right, the first thing we have is just some random data. And we need to decide who is the independent variable and who is the dependent variable. In general, x is going to be your independent. So your independent is x, and your dependent is going to be y. So when I make the scatter plot, I'm going to put the x in L1 and the y in L2. So I'm going to go ahead and enter my data. Oops. And then I'm going to arrow over to my next column and enter the y data. So 6, -1, -3, -1.5, 5, and 10. All right, first thing it says is to make a scatter plot. So make sure you turn your plots on. So do second stat plot. And then mine is plots on already. So I'm going to graph, and you see how my graph isn't all that helpful. So I'm going to adjust my zoom. I'm going to go to zoom, and I'm going to choose zoom stat number 9. Now when I do that, I see that I have what looks like a parabola. So I'm going to use a quadratic regression for this one. So just like last time, press your stat button, arrow over to calc. This time we want quad reg, which is number 5. L1, L2. I'm going to store my regression in Y1. So I'm going to go to vars, yvars, function, Y1. And then I'm going to come down and I'm going to say calculate. And right here I have my quadratic regression. It's telling me it's ax plus by plus c. So a is 1.678. B is -3.907, C is -0.229, R squared is 0.95699, blah, blah, blah. So I have a very strong correlation here. So I'm going to write down my regression formula, y equals, and I'm going to round to 2 decimal places, so 1.68 x squared minus 3.91x minus 0.23. Correlation coefficient, r squared equals 0.96, which is a really good model. So now we're going to look at some other scatter plots. And just looking at the data on the plots, we're going to decide, does this look like a quadratic regression would be better or a linear regression? So this first one, I see what looks like a parabola, like that. So I'm going to say a quadratic regression. This other one definitely looks more linear to me, so a linear regression. This one in the middle, I'm not really sure, because I can see a parabola here. I also see another parabola there. Or in the middle here, I can see a line. So I'm not sure. So for that one, it's probably best to try both. And then compare the regression correlation coefficients and see who works out better. So just a reminder of the steps to do: enter your data in your lists, create the scatter plot of the data, look at the plot and see which one looks like a better fit. That could save you some time. If you are not sure, do both and see what happens. So let's do an example here. We have data from the National Health, U.S. health expenditures for 1988 to 1992. Which one is the independent variable? Well, your independent variable is going to be the year, and your dependent variable is the expenses. This is because you are controlling when you're checking the expenses. You control the year that you check. So that is your independent variable. We're going to make a scatter plot on our calculator, and we're going to decide if this looks like a linear regression or a quadratic regression. So let's go in and clear out what we have. Clear, enter. I also want to get rid of that graph that I had. And now I'm going to press Stat, Edit, and I'm going to go ahead and enter my data. So pause your video here and enter your data. Okay, so I have entered the data in my calculator. Now I'm going to make my scatter plot. So I am going to make sure that my plot is turned on. I have plots on. Press graph. Not seeing anything, so adjust your zoom. I'm going to go to 9 zoom stat. All right, this looks like a line to me. So because this looks like a line, I'm going to do a linear regression. So stat, calc, come down to linear regression, which is number 4. L1, L2. Let's go ahead and store our regression in Y1. So bars, Y bars, function, Y1, and calculate. So this is what I get. So my equation is going to be Y equals 64.77x minus 128,200.56. That's my equation. Then it says use your equation to estimate what year national health expenditures reached $1 trillion, which is 1,000 billion dollars. I'm going to take my equation. I know that I want the y to be 1,000, and I'm going to solve for x. So add the 128,200.56 to both sides. So let's get out of here. 1,000 plus 128,200.56. I get this. 129,200.56 equals 64.77x. And then divide by 64.77. And I get 1994.75. So this tells me that during the year 1994, we will hit the $1 trillion expenditure, and the 0.75 suggests to me that's going to happen somewhere around September of that year. All right, the next thing is, what was the national health expenditure in 1999? So now use the same equation, 64.77x minus 128,200.56. Plug in 1999 for your x. So let's go to our calculator. 64.77 times, not minus, times 1999 minus 128,200.56. And I get 101,274.27. Wait a minute. Look at, somehow I dropped a 1 there. So this isn't right. I gotta do this again. 64.77 times 1999 minus 1, I missed that 1 again. 128,200.56. Let me double check, make sure I got it in right. I think I do this time. That's better. So $1274.67 billion. All right. Our next example comes from the field of medicine. It has to do with the concentration of medicine in a patient's bloodstream. So we have information on time after they have received the medicine and the concentration in their bloodstream in milligrams per liter. So which variable is independent and thus goes in L1? Well, you control when you take the measurements, so that is time. And then your dependent variable is going to be the concentration. All right, pause your video and make your scatter plot. Pause your video now. All right, so here is my data entered. Let's graph it for the scatter plot. Again, I can't see it, so adjust your zoom. Easiest thing to do is a zoom stat since we're doing statistics. All right, this looks like a parabola to me. So therefore, we're going to use a quadratic regression. All right, so let's do our regression. Stat, calc, I'm going to select number 5, the quadratic regression. I'm going to go ahead and store my equation in y1. Try that again. Okay, I'm storing it there. Calculate. So there's my equation. Notice the r squared value is very high. It's 0.9777, so we have a really good correlation. My equation is going to be, it gives me A is negative 74.8 x squared plus 170.96 x plus 3.77. And I'm going to, I went to 2 decimal places. This is 74.82 x squared. So then what's the concentration of medicine in the blood after 1.75 hours? Just plug in your 1.75. So y equals negative 74.82 times 1.75 squared plus 170.96 times 1.75 plus 3.77. While we're at it, let's take a quick look at this regression graph. Check that out. Isn't that pretty close? All right, so let's come out of here and let's put our calculation in. Negative 74.82 times 1.75 squared. Whoops, squared. Oh. Just do squared. Plus 170.96 times 1.75 plus 3.77. See what we get. I get 73.81. grams per milliliter. All right, now take a look at the chart and see how we have a 1.5. After an hour and a half, it's at 84. And then after 2 hours, it's at 50.1. So I would expect my number would be somewhere between 84 and 50.1. And I got 73.81. So yes, this is a reasonable answer. So make sure when you're doing these kinds of problems, take a look and see if your answer makes sense. All right, thank you for watching. That's it for today's lesson. Have a great day.